I've just opened the for loop start.xlsm file. I will press Alt 11 to get to the Visual Basic editor. In this VBA project, in the code module, I have a subroutine called for loop intro. On the first line, I declare a dynamic array called employees, and this is a string array. In the second line, I redimension it. So here I declare that the indexes will go from 0 to 4. Then I have a variable called I, and I declare it as a long variable. And I have two other variables declared as long variables, first index and last index. Then I populate my employees array with some names. Previously, when we printed out the names that this employees array contains, I had to put as many debug.print lines as the number of names or employees we have in this array. But that is of course problematic. Instead of writing a new line for each item in the array, we should simply go through our array. So we should go through our values, our collection of values or names. And this concept of going through a series of items in programming is called iteration. In VBA, we can use loops to iterate over an array. Iterating means going through the elements one by one. As the name of the subroutine suggests, in this video we will familiarize ourselves with the for loop. We know that our array is indexed from 0 to 4 now, but of course it is not always the case, so we need a way to get the indexes dynamically. So we will know the first index that we have to iterate and the last index that we also have to iterate. Let's save the first index of the array into the first index variable. To do that, we can use the lbound function. Lbound stands for lower bound, and it requires an array as an argument. And once I press enter, you see that now the L and B have been capitalized and it is in blue, so lbound is in blue. So this function, this lbound function, will return the lower bound of our employees array, so it will return 0, the first index. We have another function for finding the last index of an array, and it is called ubound, which is short for upper bound. Of course, it takes an array argument, an array as an argument, and of course we will provide our employees array to it. And so this ubound function will return the number 4 to us, and let's actually confirm this quickly. So let's use debug.print, and let's print out the first index first. So 0 has been returned, and now quickly I will print out the last index or the upper bound of the array, which is 4. Okay, everything seems to be working fine. Now we have the first index and the last index of our array. So now it's time to implement our for loop. We need to start a new line with the for keyword, and now we need to define an iterating variable, and this will be the variable I. It is very common actually to name your iterating variable as I. I is short for index. And we have to assign the value of the first index to I. So the looping variable or the looping will start at the first index. And then we need to use the to keyword, and we have to define the last index or the value where the looping variable should stop. And this will be the last index, of course. Let's press enter. So the two keywords, the for and the to, have been capitalized and they are in blue. Our for loop would not work like this. We have to add a next statement onto the new line. And now our for loop is complete. Notice that the next statement is of course a keyword. But of course now we are not doing anything, so if I run this code, nothing will happen in this for loop. But I still want to print out the names that our array contains. So I will add a debug.print line here, and I will say print employees at the I index. So now we have this looping block in our code, and what happens is that we say that we have the looping variable I, and initially its value is 0, but it will go up to the value 4, so up to the last index, which is 4. So first the value of variable I is 0, and we will hit this line of code with the value 0 here. So the name Emma will be printed out to the immediate window. Then the next statement will be hit, and the next statement will send us back to our loop, but our looping variable will be increased by 1. So this variable I will be increased by 1. So in the second iteration, this I will be 1, so the name Paul will be printed out to the immediate window because we will retrieving the value at index 1 from the employees array. Then again the next statement will be hit and we will be back into our loop, but this time the value of variable I will be 2. So the name Jane will be printed to the immediate window. When the value of variable I will be 4, then the name Emily will be printed to the immediate window. But we declared that we only want to loop until the last index, whose value is 4, so it is the upper bound of our array. So when we hit the next statement and the looping variable I, will be increased, then nothing will be printed out, so we will not hit this line, because I will contain the value 5, which is higher than the value up until we want to loop. So we will exit our for loop as soon as the looping variable reaches a value that is higher than the value that we defined here or declared here. Let's confirm that this is working. I will make the immediate window bigger, and indeed Emma, Paul, Jane, Joe and Emily have all been printed out. So our for loop ran 5 times, and the looping variable was indeed increased at each iteration. Looping or iteration is a very important topic. Imagine that you have an Excel table. In order to process the table in VBA, you will have to loop through it or iterate over it. Of course, it's up to us how we iterate over it. We can iterate column by column or row to row. It depends on the situation and our needs. I want to mention one more thing about the for loop. It's possible to put the looping variable next to the next statement, and our code would work the same. So if I run this, the result is the same, but it's not necessary to put the looping variable here. And sometimes actually you will see that the looping variable is there, but only as a comment. And this can be useful if we have nested loops. So if we have loops that are nested into each other, so there are more than one looping variable. In that case, it could be a good idea to put your looping variable next to the next statement, so it will be obvious to which loop your next statement belongs. But usually I just omit the looping variable, because simply it is not necessary to use it next to our next statement. So far we've been iterating over our array from the first index to the last index. So the looping variable is being increased in each iteration. We could actually decrease it, so we could go from last index to first index as well. And that way, first the name Emily would be printed out, and then Joe and Jane and so on. To do that, of course, we have to assign the value of the last index to our looping variable. So our loop will be start at value 4. And of course, then we have to define that the loop should stop at the first index, so at index 0. But if we are doing this, so if we want to decrease the looping variable, then we have to add something here at the end of the first line. We have to add step -1. You see the step is a keyword, it is in blue and the S was capitalized. And now what will happen is that we will start looping from the 4th index or from value 4, so the name Emily will be printed out. And then when we hit the next statement and we loop again, then because of this step -1 declaration, the looping variable will be decreased by 1 at each iteration. By default, it would be increased, but we don't want to do that. We want to decrease it, so we want to go from 4 to 0. Let's see what happens if I run this code. So we see exactly what we wanted to see. We see Emily printed out first, then Joe, then Jane, and so on. So this is working, and there is really not much to add here. If you want to reverse your for loop, so to go from the largest index to the smallest index, then you have to use the step keyword here, and you also have to define by how much the loop-in variable should be decreased at each iteration. You can understand it as -1 will be added to the loop-in variable. As a result, the loop-in variable will be decreased by 1 at each iteration. The best practice is to choose the types of our variables in a way that when we run our code, the least amount of computer memory will be required. I have declared these 3 variables as longs and not as integers. This code is for educational purposes, so we see that the upper bound of the array is 4, so the loop-in variable and the indexes could be integers. However, my thinking here is that someone might want to use this code and extend it. And it might happen that an array has so many indexes that an integer would not suffice. In an Excel worksheet we have more than 1 million rows, and my thinking is, what if we want to process 100,000 rows? In that case we would need to use long variables instead of integer variables. So the usage of the long data type for these 3 variables is intentional on my part. Even if we work with little data now, I want to write code that wouldn't crash even if we had a lot of data. Let's check our loop. Now we are looping from the first index to the last index. So the loop-in variable I is increased by 1 at each loop-in or at each iteration. We initialize it to be 0, so the starting value is 0. Then we print out the employee at index 0, so we print out Emma. But I've added an extra line of code here that decreases the loop-in variable by 1. So in the first loop, the loop-in variable will be loop-in variable -1, so 0 -1. So before hitting the next statement, our looping variable is not 0 but -1. But then the looping variable is immediately increased by 1. So in the next iteration, it will be 0 again. So we will print out Emma again. And then again, this line is hit, so this assignment is hit. And it actually might be confusing that I'm using the same variable on the left side and on the right side as well. But first the right side is evaluated, so first we arrive at the value 0 -1, so -1. And then this -1 value is assigned to the looping variable. But then we hit the next statement and our looping variable will be increased by 1, so again it will be 0. And again the name Emma will be printed out, and again we decrease the looping variable, and again we increase it, and again it's 0 when we hit this line of code. This is what we call an infinite loop. This is something that you should avoid at all cost. No matter what programming language you use, an infinite loop is always a bad thing. Once your code hits an infinite loop, it will be stuck in there theoretically forever. Of course it will not be there forever, because at one point we will stop the execution of the code manually. But it can also happen that an infinite loop ends because the computer simply runs out of memory. In this loop we are not doing anything that requires a lot of resources. But there are loops where each iteration uses additional computer memory, and at one point even an infinite loop will be stopped because the computer just runs out of memory. I will let the code run, and we will have to stop the execution of the code manually. What you will see is that the name Emma will be continuously printed out to the immediate window. So actually I will make the immediate window a bit bigger. I will press 5 and let's see what an infinite loop looks like. It doesn't look good. So the name Emma is printed out constantly. But after a while the immediate window is not even updated. However, you see that the code is still running, so the process is still running. If you have an infinite loop and you have to stop it manually, then simply press escape. Now unfortunately we reached a point when the process is unresponsive. So with escape I stopped the code execution, but now I just have to stop the whole process because escape cannot stop the process anymore. So I have to go to my task manager, Control Delete, and you see that Microsoft Excel is not responding, so I will just end the task. And immediately the task has ended. Now let me open this file again, and let me start the infinite loop again. But now after I start running it, in a few seconds I will press escape to stop the process or stop the code execution manually. So I press F5, we are in the infinite loop, and now I will press escape. And now Visual Basic said the code execution has been interrupted, so I can click on end, and I'm back to my code. And see how many times Emma was printed out. Yeah, a lot of times. The biggest takeaway here that whenever you write a loop, think about what will happen in your loop and try to avoid an infinite loop. Once you are in an infinite loop, however, if you realize it quickly enough, you can press escape and then the code execution will stop manually. Otherwise, the process might become unresponsive, and then you have to kill the whole process, so you have to kill your Excel process in your task manager, if you're using a Windows machine, of course. Either way, you've seen examples on how to do both. But the best thing you can do is to try to avoid infinite loops at all cost. We're still working with the employees array that contains 5 employees. It might happen that we want to search for a specific value in an array. In that case, of course, we have to iterate over an array so we can use a for loop. Let's say that we want to find Jane in the array. Jane is at index 2, so it's not necessary to look at indexes 3 and 4 if we are looping from index 0 to 4. Imagine that you have 50,000 names in your array, and Jane is at the same index, so at index 2. As soon as we find Jane, the good practice is to stop looping, because if we stay in the loop for longer than needed, then it's just a waste of time, a waste of resources. Let's check our loop. I have modified it a bit. We are looping from index 0 to index 4. We are printing out the employee that is at the current looping variable, but we also have an if block, and here we check if the employee at the current looping variable equals Jane. If yes, then we will print Jane has been found at index, and I concatenated the looping variable so we will know what index Jane has. And there comes the important part. I'm using the exit for keywords here or statement here. When the code hits exit for, then we will stop looping altogether. So we will not see the names Joe and Emily printed out to the immediate window. This will be the last message that we will see printed out. I'll press 5 to run the code and confirm this. Indeed, first Emma has been printed out at index 0, then Paul at index 1, then Jane at index 2, then this condition evaluated to true, so the code here is reached. So we see this message printed out to the immediate window, and we are exiting the for loop, so Joe and Emily are not printed out. Exiting a loop is simple, but it is very useful. In programming, it's a good practice to stop looping when looping is not necessary anymore. I have just opened the for loop with two-dimensional array start.xlsm file. In this file we have this small range of cells. In column A we see titles, in column B we see first names, and in column C we see last names. As the name suggests, we are going to create a two-dimensional array from this range of cells, and we are going to loop through it. Let's open the Visual Basic editor. In the code module I have a subroutine called loop two-dimensional array. I'm declaring an employees array with the variant data type. If I declare an array as a variant, it means that the array can hold any type of data, so numbers or strings or whatever. Of course, now I know that it will hold strings, but I have to assume that someone else might want to use this code as well, so it's better if I make sure that all kinds of data can be saved into the employees array. Here I have two looping variables, I and j. What we usually see in VBA code is that if we have one looping variable, that is the I variable, which stands for index, but if there is a second looping variable, that is usually the variable j, and it's the j because this is the next letter in the English alphabet after I. I have declared 4 additional lone variables. In these 4 variables I'm going to save the upper and lower bounds of our two-dimensional array. Don't forget that in case of a two-dimensional array, we need to specify two indexes when we want to retrieve a value. And we can think about the first index as the row index and the second index as the column index. So if I go back to the worksheet, the row indexes will go from 1 to 3 and the column indexes will also go from 1 to 3. In the next line of code, I save the range A1 to C3 into my employees variable. And in earlier videos, we've seen that if I do that, so if I save a range into an array, then the indexes will start from 1 and not from 0. This is why I said that in the first dimension, we will have the indexes from 1 to 3, because they will be the row indexes. And in the second dimension, we will also have the indexes from 1 to 3. And they will be basically the column indexes. So A will be the first index, B will be the second index, and C will be the third index. Let's get back to the editor. In these two lines, I'm getting the indexes of the first dimension. I have the first row index variable, which takes the lower bound of the employees array. But because this is a two-dimensional array, as the second argument, I pass the value 1, because here I want to get the lower bound of the first dimension of the array. So it will be the first row index, which will be 1. Then I save the last row index. I use the ubound function to get the upper bound of the employees array, and I also specify that I want to get the upper bound of the first index. We have 3 rows, so the last row index will equal to 3. I'm saving a lower bound into the first call index variable, but now I'm taking the lower bound of the second dimension of the array, so the lowest column index, which will be 1. And I'm saving the upper bound of the second dimension of the array, so the column index, into the last call index variable. Then I will iterate over this array by rows, which means that I'm having a nested for loop here. So this is the first for loop, and the second for loop is nested inside my first for loop. In the outer for loop, I use the looping variable I, and I initialize it to the first row index, which will be 1. And we're going to loop until the last row index, which will be 3. Then I start my nested or inner loop, but in this loop, I use the j looping variable, and I initialize it to the first column index, which is 1, and I will loop until the last column index, which is 3. The code will print out the employee who is at row index or first dimension I, and column index or second dimension j. When this loop runs, what we will see is that our range of cells will be printed out like Mr. Mark Lenya, Mr. Frank Smith, and Miss Livia Ulrich, so row by row, because the row index or the first dimension is at the outer loop. What happens is that the variable I will be 1 at the beginning, and then we are immediately hitting the second loop. And in the second loop, j will be 1 as well initially. So first we will print out the employee that is at indexes 1 and 1. So first row, first column. Then we hit the next statement, and this next statement belongs to the inner loop. And when I have nested loops, I like to have the looping variables as comments next to the next two statements. So it's clear for everyone that when this next statement is hit, then the j looping variable will be increased, and we will back to the next iteration of this inner loop. In the next iteration, in the inner loop, j is increased by 1, so now j will be 2, but I hasn't been increased. When we finished with the inner loop, then the variable I will be increased, so then it will be 2, and then we will hit the inner loop again. But here we are still at the second iteration of the inner loop, and I is still 1, but now j is 2. So we will print out the item at the first row index, but second column index, which will be basically cell B1, so Mark. Then again we hit this next statement, and then again we are back to this for loop. So we are at the next iteration, and j is again increased by 1, so j will be 3 now. So here we will print out the employee at row index 1 and column index 3. which will be my surname here. When we hit the next statement again, j is increased again. However, j will be 4 for the next iteration, and we are looping only until j is 3. So the last column index is 3 here. So we will not print anything else out. We will exit this for loop. So now the variable I will be increased, and now the variable I will be 2. So the row index will be 2. And again we will hit the inner loop, and initially the column index will be 1, then 2, then 3. But this time the row index will be 2. So we will print out the second row. Once j is 4 again, so once j is more than the last column index that we defined here, we hit this next statement, so I will be increased to 3. So in this inner loop, the last row, the third row, will be printed out. The row index will be 3, and the column index will be 1, 2, and 3. And then the column index will be 4, but we loop until only 3, so the third column index. So again, the variable I will be increased, but now the variable I will be 4, which is a bigger number than the last row index, which is 3. So we will exit the outer loop as well, and we will hit this debug.print statement. So we will just print out some dashes. And I have an example for looping by the columns, so reversing the logic, but actually I will type exit sub below the debug.print line. If you're inside the subroutine and you type exit sub, then you can exit your subroutine early. So as soon as this line of code is hit, we will jump to the end of the subroutine and we will skip this loop or the rest of the code in the subroutine. Let me run this code so we can confirm that the array will indeed be printed out row by row. I'll press F5 and I will make the immediate window bigger. And indeed we are printing out the names or the data row by row. This is the first row, Mr. Mark Lenya. And you see this is indeed the first row. Then the second row is Mr. Frank Smith. Indeed, that is the second row. And then the third row is printed out, Miss Livia Ulrich. And indeed, Miss Livia Ulrich is in the third row. And then these dashes are printed out. And then we are exiting the subroutine, so we are not hitting the second loop. So we don't print out anything because we never reach this loop. But of course, we will discuss what this second loop is doing. In this nested loop, the outer loop iterates over the first dimension of the array, which can be considered as the row index. And the inner loop loops through the second dimension of the array, which can be considered the column index. We will reverse the two loops. The outer loop will iterate over the second dimension of the array, and the inner loop will iterate over the first dimension of the array. I think that the topic of nested for loops can be quite confusing at first, so let's start checking these nested loops. In the outer loop, we initialize the variable I, so the looping variable, to the first column index, which is 1, and we will loop until the last column index, which is 3. So in the outer loop, we have the second dimension of the array. In the inner loop, we use the variable looping variable j. We initialize it to the first row index, which is 1, and we loop until we reach the third row index, which is 3. And inside the inner loop, we have one line of code where we will print out the employees based on first dimension index and second dimension index, or row dimension index and column index. So this time what will happen is that so the first three values that will be printed out will be Mr., Mr. and Miss. Then the second three values will be Mark, Frank and Livia. And the third three values will be Lenya, Smith and Ulrich. Let's go back to the Visual Basic Editor. Now let me explain what will happen in these for loops, iteration by iteration. So the variable I, the variable for the second dimension, will be initialized to 1, and we will loop until 3, so the third column index. Then we will immediately hit the inner loop. We initialize j to be 1, so the first row index, so the first index of the first dimension of the array. And we will loop until the last row index, which is 3. So when we hit the debug.print line the first time, j, the row index is 1, and I, the column index, is also 1. So basically we are hitting cell A1. Of course, we are actually not getting the value from the cell, but we are getting the value from the employees array. But we saved the range of cells into the employees array. This is why I'm referring to the cells. And maybe it will be easier to understand what is going on if I refer to the cells as well. So after Mr. here will be printed out, then we hit this line, the next line, and this line belongs to the inner loop, so the variable j will be increased by 1. So now the row index, or the first dimension index, will be 2. So we will print out the employee at, or the data sort of, at row 2 and column 1, which will be cell A2. Then again we hit this next statement, so the loop-in variable j will be increased again by 1. So it will be 3. So we print out the employee that is at row index 3 and column index 1. So we'll print out miss. Then we hit the next statement, so j will be increased, but j will now be 4, which is bigger than the last row index. So we are back to the outer loop. Actually, we will hit this next statement, so the variable I will be increased by 1. So we are now back to this outer loop. And now the value of variable I will be 2. And again we hit this inner loop, and first the value of j will be 1, then 2, then 3. But the variable I will not change. So we will print out the data that is at row index 1 and column index 2. So cell B1. Then we will print out the data at row index 2 and column index 2. So cell B2. Then we will print out the data that is at row index 3 and column index 2. So Livia, cell B3. And then j will be increased, so j will be 4. So we will exit this loop because 4 is bigger than 3. And then the variable I will be increased again, so now the variable I will be 3, so the column index will be 3. So now we hit the inner loop again, but this time the variable I is 3. But initially variable j will be 1 still. So first we will print out the data at row index 1 and column index 3. So it will be cell C1. Then j will be increased, so we will print out the data at row index 2 and column index 3. So Smith will be printed out. Then j will be increased again, so now we will print out the data at row index 3 and column index 3. So Ulrich will be printed out. Then j will be increased to 4, so we will exit this inner loop once again. And then I will also be increased by 1, so it will be 4. But because 4 is bigger than the last column index, which is 3, we will exit the loop and then exit the subroutine. We will not print out anything else. I will run the code to see that indeed the data will be printed out column by column. But notice that our first loop will run as well, and then we will have these dashes to sort of separate the results of the two loops. We are interested in all the messages or all that is printed out below the dashes. Let me press F5 to run the code. And I will make the immediate window bigger. I can make it smaller a bit so we will only see the dash. Okay, I can scroll. I can also scroll, of course. So now we don't see anything that is printed out by the first loop, but we only see the dash and what is printed out by the second loop. And indeed, the data now is printed out column by column. Column A is printed out first. Then column B is printed out. And then column C is printed out. I hope that you've found working with nested loops challenging, but I also hope that my explanations helped clarify things. Nested loops in VBA are typically used when we process two-dimensional arrays, so what we did just now. My advice to you, however, that if you can avoid a nested loop, then avoid it. If you have an alternative to a nested loop, then the alternative is usually faster and less confusing than a nested loop. But this is just some advice for the future. While you are learning VBA or your first programming language, it is very important that you understand the concept of nested loops. They can be quite confusing and challenging, and sometimes we must use them.